शेयर करें ना सर स्लाइड्स तो
स्लाइड्स the folder 3 and AC7. نو دا خو 8 واسطه خو به 2 تاریخ ته کمپلیټ شي بیا 10 ته
10 जनवरी پورې ده سر
ها
بس ټیک شو 8 ویک شي پوره شي
صحیح دیکھیں لګه هغه سلایډونه هو
دا به سر لګ
پدا ها صحیح ټیک Hello, can you hear me? Hello. Hello.
जी सुन रहे हैं सर
सुन रहे हैं अच्छा
जी
okay welcome to this lecture of advanced calculus. This is the 7th lecture of the course and you know that today is 26 December 2020. In our previous lecture we defined higher partial derivatives. That is, we confined ourselves to second order partial derivative. Up to second order partial derivative means we consider a function f in two variables, x and y, and we define their partial derivatives with respect to x and y. And also the mixed partial derivative, that is second order partial derivative, del f square divided by del x del y and del where is this slide? What happened? Wait a minute. बंद आ रहा है, टेक्निकल प्रॉब्लम है थोड़ा सा.
ओके सर, ओके.
सर समझ चलो
स्टार्ट हो जाएगा सेकंड लेक्चर.
तो स्टार्ट को
आमिर स्टार्ट को का ना.
हाँ
او بیا دا سکرین پر راغی هغه غایب شو سلایډونه سایډ ته سلایډونه دي.
دا
ها په دا یې کېږي اولې په میز کې بیا غایب شو. स्लाइड विजिबल है.
यस
Yes,
सर,
sir.
विजिबल है.
हाँ
साइट पर भी विजिबल है.
क्लियर है स्लाइड.
साइट के भी विजिबल है. जी सर.
नहीं ये स्लाइड आपको नजर आ रहा है.
Yes, sir. Clear है, सब कुछ clear है, sir.
बिल्कुल सर,
अच्छा
नजर आ
क्लियर
रहा है.
है. ओके थैंक यू. ओके लेट अस स्टार्ट दिस course of advanced calculus. I was saying that in previous lecture we defined mixed partial derivatives of the multivariate function, and we confined ourselves to second order partial derivative. Today we shall discuss directional derivative and gradient vector. Before defining directional derivative, we recall some basic concepts from vector analysis. First is this definition. Length or magnitude of a vector. You know that vector is a quantity which has direction and magnitude. We consider a vector V in 3 space or in 3-dimensional space. This V is equal to V1 I vector plus V2 J vector plus V3 K vector. This is a vector in 3 space, and V1, V2, V3 are the component of this vector along these unit vectors I, J, and K. The length of this vector is denoted by V absolute and is defined as V1 square plus V2 square plus V3 square under root. This is the definition of magnitude or length of the given vector in 3-dimensional or 3 space. If you remove this third component from the definition, you get a vector in 2 space or 2-dimensional space. In that case, the magnitude of V will be V1 square plus V2 square under root. So in this way, we define the magnitude of a vector, where V1, V2, V3 are the component of the vector along I, J, and K. For example, this V is equal to 2I plus 2J minus K. Now you see this arrow over I, J, and K. This denotes that I, J, and K are vectors. In hand written work, we put this arrow over V to show that this V is a vector. And typed work, in typed work, we denote a vector by bold alphabet. That is, this V will be bold without this arrow over here. So these arrows shows that these are vectors. And we use these arrows in handwritten, remember that we use these arrows in handwritten work. And in typed work, these vectors are represented by bold letters without these arrows. अब चूंकि ये slide handwritten है, so I put this arrow or V and V1, V2 and V3 and so on. So the length of this vector is, you see this V1 is here 2, so 2 square plus V2 is also 2, so 2 square, and V3 is minus 1, so minus 1 square whole under root, which is equal to 4 plus 4 plus 1 equal to 9 under root, which is equal to 3. So the length or magnitude of this vector V in this case is 3. Next, we recall the definition of unit vector. If you have a vector and its length is equal to 1, then this vector is called unit vector. It is clear from the name of this unit vector. Any vector whose length is 1 is called unit vector. For example, if we have a vector V which is equal to 1 over 2 under root I vector plus 1 over 2 under root j vector. So by definition of length or magnitude, V absolute is equal to 1 over 2 under root square plus 1 over 2 under root square whole under root, which gives you 1. So we see that this given vector V is a unit vector, means its length is 1. Next, we recall the definition of unit vector in the direction of a given vector. Unit vector in the direction of given vector, if V is a non-zero given vector, then V divided by V magnitude is a unit vector in the direction of V. This V divided by V magnitude is a unit vector. Why? Because if you take absolute of this, so this will be equal to V absolute divided by V absolute equal to 1. So this is a unit vector, right? In the direction of given vector V. Now we come to, with this background, we come to the definition of directional derivative. By definition, the directional derivative of a function f in 3 variables x, y, z at a point P x naught, y naught, z naught is the derivative of the unit vector u. U is a unit vector whose components are u1 I vector plus u2 I vector plus u3 k vector, u1 I vector plus u2 j vector plus u3 k vector. This is a unit vector, and the directional derivative of the given functions in the direction of this unit vector is defined as, denoted by df or dt in the direction of unit vector u. P is a point. At the point P is defined as limit s approaches 0 f x naught plus s u1 comma y naught plus s u2 comma z naught plus SU3. These U1, U2, and U3 are the components of the unit vector minus F x naught, y naught, z naught divided by S, where this limit S approaches to 0. If this limit exists, then we say that this is the df or dt is a directional derivative in the direction of unit vector u at the point x, the p naught. Another notation for the directional derivative is capital D, that is D denote the directional derivative in the direction of unit vector u of this function f at the point p naught, and it is read as the derivative of f at p naught in the direction of this unit vector u. Right, so this was the definition of directional derivative, but remember that it is very difficult to use this definition for finding the directional derivative of a given vector function in the direction of unit vector in practice. अच्छा, अगर यह definition difficult है, then how we will find directional derivative of a given function in the direction of unit vector? For that purpose, we have a simple formula. The directional derivative of the function f in 3 variables x, y, z in the direction of unit vector u equal to u1 I vector plus u2 j vector plus u3 k vector in 3 space is given by this simple formula. Directional derivative of f in the direction of unit vector is equal to partial derivative of f with respect to x into this u1 component plus directional partial derivative of f with respect to y into this second component u2 of the unit vector plus partial derivative of f with respect to z into this third component u3 of the unit vector 3. So this remark says that the definition of the directional derivative in the direction of unit vector is too difficult to find the directional derivative of any given function in the direction of unit vector. So in the if this is not easy task, then how do we find the directional derivative of the function in the direction of unit vector? For that purpose, we use this simple formula. ये formula आप याद रख रहे हैं? If you are given a vector function in 3 variables or in 2 variables, if it is in 3 variables, we use this formula. If it is in 2 variables, we delete this third term from the formula. So we use this simple formula for finding the directional derivative of the given function in the direction of unit vector at certain points. अगर point दिया गया है, अगर नहीं फिर just find directional derivative of the function in the direction of a unit vector. The concept is clear by the following example. Example में क्या है आपके पास? Example says find the derivative of the function f in 2 variables x and y. कैसे डिफाइन किया हुआ इस फंक्शन को हमने? It is equal to x square plus xy at the point x naught y naught, which is equal to 1 2. that is x naught is 1 and y naught is 2, in the direction of unit vector u, which is equal to 1 over 2 under root I vector plus 1 over 2 under root j vector. So we have to find the directional derivative of the function f in two variables at the point 1, 2 in the direction of unit vector u. Using this formula में आपके पास क्या है? First try to find out partial derivative of f with respect to x, then partial derivative of f with respect to y, and then partial derivative of this f with respect to z. But since in this example our function is in two-dimensional or in two space, so we omit this third term from the formula. We simply need to find partial derivative of f with respect to x and then partial derivative of f with respect to y. In partial differentiation, if you are differentiating the function f with respect to x, you keep y as constant. And if you want to differentiate the function f with respect to y, in that case, you keep x as constant. Now, here your function fxy is equal to x square plus xy. And we differentiate this f with respect to x. We keep this y as constant. So partial derivative with respect to x will be 2x plus y is constant. So take this y outside and differentiate x with respect to x, which is 1. So you get that partial derivative of f with respect to x is 2x plus y. Similarly, partial derivative of f with respect to y, now keeping this x as constant and differentiate f with respect to y, and you get x. Your unit vector is 1 over 2 under root I vector plus 1 or 2 under root j vector. So u1 is 1 over 2 under root and u2 is also 1 over 2 under root. Now using the formula, by definition, the directional derivative of f in the direction of unit vector is del f or del x u1 plus del f or del y u2. Putting the values, you get 2xy x plus y into u1, which is 1 over 2 under root, plus partial derivative of f with respect to y is x and u2 is 1 over 2 under root. So this is the directional derivative of f in the direction of unit vector u. But we are trying to find this directional derivative of f in the direction of unit vector u at the point p naught. Point is also given. And here in the point, your x is 1 and y is 2. So putting the value of x and y, you get 2 times 1 plus 2 into 1 over 2 under root plus your x is 1 into 1 over 2 under root. Simplifying this, you get 5 divided by 2 under roots. So the derivative of the given function fxy, which is equal to x square plus xy, at the point 1, 2, in the direction of unit vector u is 5 divided by 2 under root. So this is the definition of solution of this example. Now here is one simple exercise for you. This is homework. You can do practice on it. Now look at the slide. It says that find the derivative of the function given as below at the point P naught in the direction of this vector A. Don't be confused. Here we are using instead of U this vector A. In the first example, function is defined as function is in two variable, which is defined as 2x square plus y square. Point is -1, 1, and the vector is A, which is equal to 3i minus 4j. But remember, in the example, U was a unit vector. But this A is not a unit vector. If you take its magnitude, which will be 9 plus 16 under root, which is equal to 5, 25 under root, which is equal to 5. So the magnitude of the vector A is not equal to 1, but it is 5. अब आपने करना क्या है? Do not use these components 3 and -4. इसको आप पहले कन्वर्ट कर लें into unit vector. Unit vector में कैसे कन्वर्ट करेंगे? This will be converted to unit vector if you divide this A by A magnitude. अगर A को आप A magnitude से divide कर ले, then this will be a unit vector. And then you can use this the components. लेकिन डायरेक्ट यहाँ पे आपने U1 की जगह 3 और U2 की जगह -4 यूज नहीं करना. Let me repeat, this vector is not a unit vector. इसको पहले आपने unit vector पे convert करना है and then using the component. बाकी easy है. सिर्फ ये point याद रखें. Here A is not a unit vector. Similarly, in the second example, A is not a unit vector. इसको आपने convert करना है. कैसे? A को divide करना है A magnitude से. Third example, it is A is not a unit vector because it is 3 under root. So, ये unit vector ना हुआ, इसको आपने A magnitude से divide करना है, you will get automatically a unit vector. बाकी तरीका वही है जो अभी example में मैंने बता दिया. Right, next we move to the gradient vector. Directional derivative हमने define की definition discuss कर ली and tried one example, and these are three simple example for practice. Now we move to the gradient definition of gradient vector or simply gradient. BSc में आप पढ़ चुके हैं gradient, या BS में भी आप पढ़ चुके होंगे. अगर if you are a BS student, the gradient vector are simply gradient of a scalar function f in 3 variables x and y at a point x naught, y naught, z naught is the vector denoted as grad f. This is one notation for the gradient of f. f आपका scalar function है, लेकिन gradient इस scalar function का vector होगा, क्योंकि आप देख रहे हैं on the right hand side आपका vector है. So gradient of a scalar function is a vector or denoted by del f. And ये दो आपके पास notation आ गई, grad f or del f for the gradient of a scalar function f in 3 variables x and y, and is defined as partial derivative of f with respect to x, I vector, plus partial derivative of f with respect to y, j vector, plus partial derivative of f with respect to z, k vector. अच्छा, ये अगर इस राइट हैंड साइड पे आप को देख लें, ये डेफिनेशन तकरीबन वही जो डायरेक्शनल डेरिवेटिव का फॉर्मूला है वही है. वहां पे आई वेक्टर की जगह हमने u1 कंपोनेंट लिया हुआ था जे की जगह सेकंड कंपोनेंट u2 लिया हुआ था हमने, और z की दिस k वेक्टर की जगह हमने u3 लिया हुआ था। फार्मूला वही है, वहां पे चूंकि u1 u2 u3 आ रहा था, so that directional derivative was a scalar। आपके पास नंबर आ रहे थे एंड पे, कोई सोल्यूशन नंबर आ रहा है, कोई नंबर आ रहा था, बट ग्रेडियंट में पार्शियल डेरिवेटिव के साथ आई वेक्टर, विद रिस्पेक्ट टू y j वेक्टर, और विद रिस्पेक्ट टू z जब आप डिफ्रेंशिएट करेंगे f को, वही राइट दिस k वेक्टर। बाकी तकरीबन वही उसी फॉर्म में जो डायरेक्शनल डेरिवेटिव का स्टाइल था। So this is the definition of gradient of a scalar function f in 3 variables। फंक्शन हमारा स्केलर था, लेकिन उसका ग्रेडियंट हमारे पास वेक्टर आ रहा है। And this is obtained by evaluating the partial derivative of f at the point p naught, and symbolically we can write this as del f at the point p naught। The notation del f, ये notation, this ये उल्टा triangle into f is read as del f or gradient of f। जहाँ कहीं पे आप ये notation देखें, this means that gradient of f or del of f। So this is the definition of gradient of a scalar function f in 3 variables। 2 variable में ये third terms खत्म हो जाएगी आपकी, आपके पास definition आ जाएगी del f equal to del f over del x I vector plus del f over del y j vector, if your function is in 2 space। We try one example, how to find gradient of any scalar function। Scalar function is in 3 variables in this example. F of x, y, z is defined as x square plus y square plus z square। Question is find gradient of f at the point 3, 4, 12। सिंपल सॉल्यूशन है, कोई डिफिकल्टी इसमें नहीं है, ये ऑलरेडी आप पढ़ भी चुके हैं और है भी इजी, बच्चों वाले क्वेश्चन है। योर फंक्शन एफ इज एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर। फर्स्ट find partial derivative of f with respect to x, then partial derivative of f with respect to y, and then partial derivative of f with respect to z। Here partial derivative of f with respect to x is 2x, keeping y and z constant, और constant का derivative 0 होता है। And then partial derivative of f with respect to y, keeping x and z constant, you get 2y। Partial derivative of f with respect to z, keeping x and y constant, you get 2z। By formula or by definition of gradient of f, del f or del x I vector plus del f or del y vector y j vector plus del f or del z k vector। अब इस फार्मूले में आप ये डेल एफ और डेल एक्स, डेल एफ और डेल वाई, डेल एफ और डेल जेड की वैल्यू लगा दे, you get gradient of the given function, which is equal to 2x I vector plus 2y j vector plus 2z k vector। लेकिन solution यहीं पे ख़त्म नहीं हो जाता, we are given a point 3, 4, 12, we have to find the gradient of the given function at this point। अब इस पॉइंट में आपके पास x कंपोनेंट 3 है, y कंपोनेंट 4 है एंड z कंपोनेंट इज 12। डेल f इज इक्वल टू 2x I वेक्टर, x की जगह आप 3 लगा दें, प्लस 2 टाइम्स y इज इक्वल टू 4, y की वैल्यू लगा दें 4 इंटू j प्लस टू जेड, जेड की वैल्यू आपके पास 12 है हियर, वो लगा दें एंड के वेक्टर. Simplifying this, you get this gradient of f at the given point p naught, which is equal to 6i vector plus 8j vector plus 24k. This is the solution. It means the gradient of the given function f, which is in three variable at the given point p naught is equal to 6i plus 8j plus 24k. As I said earlier, if your function is in two variables, so remove the third term from the formula, you will get a gradient of the function at the given point. Next is one simple exercise for you. Find the gradient of the given points. In question 1, your function is in two variable y minus x, point is 2, 1. So the gradient of f in this case at the point 2, 1 will be minus iota plus minus I vector plus j vector. This is the answer. इसको आप खुद भी चेक कर लें. Second is, in second problem, function is in two variable or in two space, and it is defined as log x square plus y square, given point is 1, 1. Answer will be I vector plus j vector. And in this third example, you have this function gxy, which is defined as y minus x square. Point is minus 1, 0. Find the answer yourself. या आप खुद ही ट्राई कर लें. hxy is given. In fifth example, you have a function in three variables. And in sixth problem, function is also in three variable. इस ये दो तीन चार क्वेश्चन मैंने आपके लिए छोड़े. अपने आंसर एक दूसरे के साथ टैली कर लें. अगर सेम आ रहा है दिस मीन्स दैट योर आंसर इज करेक्ट. राइट, इसका आप खुद ट्राई कर लें. ये आज के लिए काफ़ी है. इन नेक्स्ट लेक्चर इंशाल्लाह वी शैल स्टार्ट अनदर टॉपिक. और नेक्स्ट लेक्चर आपका शायद मिड टर्म का आखिरी लेक्चर हो. तो नेक्स्ट वीक इंशाल्लाह कोर्स आपका ख़त्म हो जाएगा मिड टर्म का. एंड आई डोंट नो व्हेन योर एग्जाम विल स्टार्ट. इट विल प्रोबेबली स्टार्ट आफ्टर 10th of January. ये आज के लिए काफ़ी है. इफ़ यू हैव एनी क्वेश्चन प्लीज आस्क.
सर
जी जी,
आप अपने नोट्स हमें प्रोवाइड कर सकते हैं?
नोट्स ये आपके सामने, नोट्स ये है आपके सामने.
नहीं सर,
इसको
ये
डाउनलोड
तो
कर लें या आप प्रिंट निकाल लें. राइट, क्योंकि
सर ये
मेरे
जो
नोट्स दरमियान में बहुत कुछ मैंने छोड़ा हुआ है. ऐसे क्लीन फॉर्म में नहीं होंगे जैसे यहाँ पे. हाँ
सर ये जो एडवांस कैलकुलस के नोट्स है ये अभी थोड़ा क्लियर था, लेकिन जो फंक्शनल के नोट्स अभी आप हमें लेक्चर दे रहे थे वो बिल्कुल भी इतने क्लियर हमें नजर नहीं आ रहे थे.
आप ऐसे कर लें, उसको थोड़ा सा वो एक्सपेंड कर लें फिर आ जाएगा. क्योंकि इसके स्कैन तो मैंने किए हुए लेकिन ऐसे क्लियर भी नहीं आ रहे.
सर वो जूम करने के बाद और क्लियर नहीं आ रहे थे.
बहरहाल जो मैं रीड कर रहा था ना उसकी तो समझ आई होगी ना. अब ये तो एमफिल लेवल के का काम है. यहाँ पे तो क्लास में ये तो मैं प्रोवाइड कर क्लास में लेक्चर देता हूँ डिटेल से. नहीं तो वहाँ पे तो हिंट्स होते हैं, डिटेल आपने खुद भरने होते हैं. कोशिश कर लें रीड करने की. मेरे पास भी अगर है तो इसी तरह है, उससे भी कोई क्लियर वो नहीं आएगा. तो इसको ज़रा जूम कर लें या जो कोई तरीका हो सकता है कर लें।
Easy है
स्कैनिंग
सर,
में ये
सब
मसला आ
कुछ
जाता है क्योंकि मोबाइल की से स्कैन करते हैं वो इतने क्लियर नहीं होते। आपकी बात सही है, राइट। एनी अदर क्वेश्चन अबाउट द कंटेंट्स ऑफ द लेक्चर?
सर यहाँ पे हम जो यूनिट वेक्टर्स यूज कर रहे हैं उसके लिए एरोज यूज करें इंस्टेड ऑफ कैप्स, तो उसको
नहीं,
डिफरेंशिएट
हाँ
करने के
ये बात
लिए
सुने, आप अगर टाइप करना चाहती हैं तो वेक्टर्स को बोल्ड लेटर से, वी को बोल्ड, ऊपर एरो ना डालें। अगर हाथ से आपने प्रॉब्लम सॉल्व करने हैं ना, तो एरो फिर डालना होगा ताकि पता चले कि यह कोई वेरिएबल है या वेक्टर है। ठीक है, हैंड रिटन वर्क में ये एरो मस्ट होता है, इससे पता चल जाता है कि यह वेक्टर है। या अगर आप
ओके
अपना
सर।
मतलब असाइनमेंट या जो हैंड रिटन अपलोड करना चाहती हैं तो वहाँ पे वेक्टर को आपने एरो से ज़ाहिर करना होगा ताकि पता चले एग्जामिनर को या कि यहाँ पे वी वेक्टर है, नॉट ए एनी वेरिएबल, राइट?
राइट।
एनी अदर क्वेश्चन?
No question sir.
No? Okay, thank you. Then see you next week. Allah Hafiz. इसका एडवांस कैलकुलस
अल्लाह
का
हाफिज।
असाइनमेंट भी मैंने अपलोड किया हुआ है, यू कैन सी दैट ऑन द पोर्टल,
ओके
राइट? डेट वाइज 10 जनवरी है फॉर
ओके
सबमिशन ऑफ असाइनमेंट। बाय बाय।